Hey, Vsauce, Miles here. I'm here to talk to you about Chapter 10 in Sensation Perception, which is depth and size. It is a topic that I really do enjoy, and I really enjoy learning about it from the professor and learning about it on my own. And I'm really excited to teach you guys, or tell you guys about some stuff that I've really found interesting. So without further ado, here we go. So first, I want to talk about this picture. This picture is depicting different depths of perception. So as you can see in both slides, it looks, well, in the first slide, it looks as if the man is standing on a chair and the woman is pouring a man a glass. In the second picture, you can clearly see that the man is standing on a platform and is standing way far back, but our eyes perceive it as the woman is pouring himself a drink. That is perception of depth and size of objects. Cool, right? The next thing I want to talk about is perceiving depth, and Q approach to depth perception. So the Q approach is explaining depth perception that focuses on information in a retinal image that is correlated with depth in the scene. And that goes to occlusion, which is, okay, the best way I can do it is an example. So put your two hands in front of you. So one hand is shoulder length, one hand is arm's length, and then you move your head like this, and it seems as if one hand is over the other, covering the other. Then when you move your head back, it's the same. It goes back to normal. Try it. It's really great. As you can see in this photo, it is a perfect example of occlusion. So basically, occlusion is an object that covers another one. As you can see in the first photo, the circle is covering the square. In the second photo, the square is covering the circle. So it goes both ways. So there's occlusion on both sides. You can use it an example for both of your hands as well. When you do the example, you see that your left hand covers your right hand, and then you switch hands, and then your right hand will cover your left hand, and so forth. Pretty cool, huh? Next, we're going to be talking about oculomotor cues, which are depth cues that depend on our ability to sense the position of our eyes and tension of our muscles. And they're based on sensing the position of eyes and muscle tension. And good examples of these are convergence and accommodation. So convergence is basically focusing on objects that are near your eyes. So looking at something very close to your eyes, like maybe a foot or two in front of you. Accommodation would be something farther, so such as something that you're looking at 10 feet into distance, like a tree. So your eyes are looking at something and accommodating to whatever you're looking at a longer distance. And it's really cool. As you can see in this photo, in this example, are examples of convergence and accommodation. So picture on the left is convergence, where you're looking at something very close to you. And then when you look at something very close, both your eyes move inward. So it looks like as if you're cross-eyed. So you're looking a little cross-eyed, eyes are looking a little wonky. In the second example, you can see that, excuse me, you can see that the person is looking straight forward as if he's focusing on something, such as looking at a tree in the distance that is farther from him. So he has to focus his eye muscles and tension forward to get a better perception and look at whatever he's looking at. Next, we're going to talk about monocular cues, which are cues that come from one eye, hence the term monocular. There are different types of monocular cues, such as pictorial cues that are sources of depth information that come from 2D images and other pictures. Another type of cue is relative height, which are objects that are below the horizon, that are higher in the field of vision or more distant. Next, I want to talk about relative size, in which objects are equal size. The closer one will take up more of your visual field. Now this kind of reminds you of occlusion, which I talked about earlier in the video. Next is perspective convergence, in which parallel lines appear to come together in the distance. Now to me, this kind of reminds me of accommodation, because your eyes are accommodating to distances to objects in a farther distance. So your eyes' parallel lines will come together. It seems as if the lines will come together in the distance, which is really cool, but honestly it's just how you perceive things, how we all perceive things. Next is familiar size, which is judgment of distance is based on knowledge of the sizes of objects. Now you're probably wondering, that doesn't really help me, I don't really know what it means. So hopefully this example by William Epstein will explain. So in this experiment, Epstein made equal-sized pictures of coins that were positioned the same distance from each other. And so as you see in the picture below, there are two rows. So in the first row is the pictures of the coins that he actually used, and the bottom row is the actual size of the coin. So he used a dime, a quarter, and a $50. So he put the coin photos in a dark room, showed light to each coin, and then the subjects viewed the coins with one eye. And Epstein's goal was to show that under certain conditions, our knowledge of an object's size influences our perception of an object's distance. Crazy, right? That's what I thought. Now it really gives you a good example of what really familiar size is. It's really amazing. Okay, guys, so the last couple things I want to talk to you about are atmospheric perspective, texture gradient, and shadows, which are a part of monocular cues as well. So atmospheric perspective, that's a cue in which distant objects are fuzzy and have a blue tint. So basically it's saying the farther an object is, the more stuff we have to look through. And texture gradient are equally spaced elements that are more closely packed as the distance increases. So the farther you look, it looks as if more people are packed together and everyone looks smaller and smaller and looks like it's not enough space, when actually both spaces from farther and closer look the same. They're the same distances from each other. And the shadows are self-explanatory to the shadows, but they indicate where objects are located. It helps enhance the three dimension of objects to make it more reality based than anything. As you can see in this photo, this is an example of atmospheric perspective in which, as you see, the farther you look into the picture, the harder it is to see the mountains on the side, and it is a slight blue tint, and you have to see through the air and the dust particles and everything. It just makes it harder to see the farther you look in the distance. And this next photo is an example of texture gradient where clearly everyone is equal distances from each other, but as you can see, as you look farther in the distance, the people look more packed and tightly together than it does in the front of the picture, which in reality, everyone is the same distance from each other, just our perception. And this final picture is an example of shadows where, as you can see in example A, it looks like all the balls are on the checkerboard floor and you're not really sure where they're really placed. Now in the second picture, you can see that their shadows help locate the balls and see where they really are, so that the shadows from left to right indicate that if they're on the floor or in fact floating. And it's really interesting to really understand the concept. Well, alright, you guys, thank you. I really enjoyed teaching you guys this subject, and there are so many other things in this chapter that you can learn, such as motion-produced cues, disparity, and the physiology of binocular depth. There's so many more things you can learn about, and I guarantee that you will be amazed by what you learn. I was. So without any further ado, thank you all for listening to me, and I hope you all have a blessed one. All right, peace.